The next chapter is chapter 12, some applications of trigonometry. In some states the chapter number could be different, but the syllabus will be same. All states, those who have implemented national education policy, will have same syllabus, though chapter numbers may vary. Okay, so trigonometry you have learnt. Trigonometric ratios are with respect to a right angle triangle only. Now see in this figure, one person is watching Qutub Minar, and let the top at which that person see it, let it make an angle at some particular angle. Okay, this, let this be the angle, and let the person is standing at some distance from Qutub Minar. If we know this distance and the angle of elevation, then easily we can find the height of the Qutub Minar. It's not necessary to take a lengthy tape and measure it practically. So theoretically also, if we know this distance and angle of elevation, we can find the height of Qutub Minar. Now here you can see one kite is flying, making an angle of elevation here like this, and if we know the horizontal distance, this distance if we know, we can find at what level the kite is flying. And here you can see one person is seeing some object here at an angle of depression here, and if we know the horizontal length here, this distance if we know, we can find at what is the depth here, that is this distance we can easily find. So there are some textbook work examples, you can go through, all are self-explanatory. You should make a habit of reading textbook also. When you go to higher education, it will be very helpful. Even if you miss some class, then you can read the textbook yourself and understand. Now only you should make a habit of reading textbook, max textbook. I'll be directly going and solving exercise problems. First question, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. So the figure is given there. So AB, this AB is the pole, and AC is the rope, and from point C, that circus artist is climbing upon the rope, and the angle of elevation is 30 degree. So the length of the rope is known, that is 20 meter. And what should we find? Find the height of the pole, that is I should find the height of AB. What is the length of AB is the question. Now you can see that with respect to angle C, sin C, which is equal to sine of 30 degree. Sine, what is sine of angle C? It is opposite by hypotenuse. Opposite side is AB and hypotenuse side is AC. Now what is sine 30 degree? Sine 30 degree we know it is 1 by 2. 1 by 2 is equal to AB by AC. AC we know it is 20 meters. So when we cross multiply, we get 20 by 2 is equal to AB. 2 ones are 2, 2 ones are 2, 2 zeros are 0. So AB is equal to 10 meters. It's a very simple problem. Exercise 12.1, question number 2. A tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. So there is a tree. So this tree, it is somewhere here like this. B, C, AC is the tree. Due to storm, the tree will get cut here at this point, and it's going to fall this way, okay, and makes an angle of 30 degree here, okay, and the distance between the foot and the top of the tree, that is the point B where the tree fell, this is equal to 8 meters, right? Yeah, 8 meters. Now I should find the height of the tree. Now I'll take this point as D. So the height of tree is AC, okay, and AD is equal to BD, okay. The tree fell, so I should find the height of tree. Height of tree is AC. AC is also equal to AD plus DC. AD is also equal to BD. BD plus DC gives the height of the tree. Now you can check that tan of B, that is tan of 30 degree. Tan 30 degrees with respect to angle B, opposite side is DC, okay. So tan 30 degrees DC by BC, opposite by adjacent side. So what is tan of 30 degree? Tan of 30 degree is nothing but equal to 1 by root 3, and DC by BC. The value of BC is 8 meters. Therefore DC is equal to 1 by root 3 into 8, which is equal to 8 by root 3. Now similarly, what is cos of B with respect to angle B? Cos of B is cos of 30 degree. So with respect to angle B, adjacent side is BC, hypotenuse side is BD, okay. Cos 30 is adjacent side by hypotenuse side. So cos of 30 degree is root 3 by 2. Root 3 by 2 is equal to, what is BC? BC is 8 meters. 8 meters, and hypotenuse is, we don't know, BD. Now BD is equal to, when we cross multiply, we get 8 into 2 divided by root 3, or 16 root 3, okay. Now what is the height of the tree? Height of the tree is, tree height is equal to BD plus DC. BD I got as 16 root 3 plus, what is DC? DC is 8 root 3. So this is equal to, LCM is root 3. So 16 plus 8 is 24. So 24 by root 3. 24 by root 3. So in the denominator, root 3 is there, which is an irrational number. To rationalize it, I can multiply and divide by root 3. So like this I can multiply root 3 by root 3. Effectively there is no change if I multiply both numerator and the denominator by the same value. So I'll get 24 root 3. Root 3 into root 3 is just 3. So 3 1s are 3, 3 8s are 24. 3 1s are 3, 3 8s are 24. So answer is 8 root 3. 8 root 3 meters is the answer. Exercise 12.1, question number 3. A contractor plans to install 2 slides for the children to play in a park. For the children aged below 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. Whereas for the elder children, she wants to have a steep slide at a height of 3 meters and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? So the figure is like this. So for small kids, the length of height of the slide is 1.5 meters. For elder children, the height of the slide is 3 meter, and for small kids the angle of inclination is 30 degree this way, and for elder children the height of the inclination is 60 degree like this. So I'll mark this A, B, C, P, Q, R. Now what is the length of the slide is the question. That is, we should find the length of AC and the length of PR. Okay. Now in the first case, with respect to angle A, what is sine of A? Sine of angle A is sine of 30 degree. So with respect to angle A, sine of angle A is opposite by adjacent, that is BC by AC. So BC is 1.5 meters, AC is unknown. So what is sine 30 degree? You can see in the chart sine 30 degree. Sine 30 degree is 1 by 2. I'll substitute that value. So 1 by 2 is equal to 1.5 by AC, or AC is equal to 1.5 into 2. So 1.5 into 2 is 3. So AC I'll get 3. And similarly here, with respect to angle P, sine of P is equal to sine of 60 degree. So what is sine opposite by hypotenuse, that is PQ by PR. So what is the value of sine 60 degree? You can see in the chart sine 60 degree is root 3 by 2. So root 3 by 2 is equal to PQ by PR. So PR is unknown, and okay, PQ we know it is 3 meter. 3 by PR. When we cross multiply, PR is equal to 3 into 2 by root 3. So 6 by root 3. So 6 by root 3. So denominator, it's an irrational number. So to make it rational, we can multiply by root 3. Both numerator and denominator, when we multiply by root 3, effectively there is no change. So this I'll get as 6 root 3. Root 3 into root 3 is just root 3. Now 3 1s are 3, 3 2s are 6. So PR is equal to 2 root 3 meters is the answer. Exercise 12.1, question number 4. The angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degree. Find the height of the tower. Okay. So the figure is like this. A, B, C. BC is the tower, and from point A, if we see the top of the tower, it makes an angle of elevation of 30 degree. Okay. And the point A from the foot of the tower, that is from point B, is 30 meters. Now I should find the height of the tower. What is the height of BC? So this is a very simple problem. Now what is with respect to angle A, what is tan of angle A? Tan of angle A, tan of angle A is tan of 30 degree. So tan of 30 is opposite by adjacent, that is BC by AB. So tan 30 degree, what is the value of tan of 30 degree? You can see in the chart, tan of 30 degree is 1 by root 3. So I'll substitute that one, 1 by root 3 is equal to BC by AB. So 1 by root 3. So BC is unknown. So AB is 30 meters. Now BC is equal to, when we cross multiply, we get BC is equal to 30 by root 3. Now denominator is an irrational number, so we can rationalize it by multiplying by root 3. So when we do like this, we get 30 root 3 by root 3 into root 3 is 3, just 3. Okay, so 3 ones are 3, 3 tens are 30. So BC is equal to 10 root 3 meters is the answer. Exercise 11.1, question number 5. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string, assuming that there is no slack in the string. So there is a kite flying at an height of 60, it's meter, right? Yeah, 60 meters above the ground. So this is 60 meters, A, B, C. So kite is flying at point C, 60 meters above the ground, and the string AC is the string, and it's making an angle of elevation of 60 degree like this. Now I should find the length of the string, assuming that there is no slack in the ground. So usually there will be slacks, okay, something like this. AC will not be straight, it will be curved line, okay, but we should assume that it's a straight line, and we should find the length of the string. So what is AC? So this is 90 degree. Now you can see that this is a right angle triangle. Now what is tan of A? With respect to angle A, tan of A is tan of 60 degree is equal to opposite by, no, we'll take instead of that we'll take sine of 60 degree. So sine of 60 degree is opposite by hypotenuse, that is BC by AC. So sine of 60 degree, what is sine of 60 degree? So you can see in the chart sine of 60 degree, okay, sine of 60 degree is root 3 by 2. So root 3 by 2 is equal to BC is 60 meters by AC. So if I cross multiply, I'll get AC is equal to 60 by 60 into 2 by root 3 I'll get. So this is, now this is 120 by root 3. Now denominator is an irrational number, so I'll multiply by root 3 to make it a rational number. So I'll get 120 root 3 by 3, root 3 into root 3 is 3. So 3 ones are 3, 3 fours are 12, 0. So 40 root 3 meters. AC is equal to 40 root 3 meters is the answer. That is the length of the string. So exercise 12.1, question number 6. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. So there is one boy whose height is 1.5 centimeters. Okay, it's in meter. Okay, and there is one building. The height of the building is 30 meters. So this is boy's height is 1.5, building height is 30 meter. Now if I join the foot of boy and building, it will be like this. Now I'll join the top of the boy. I'll draw a perpendicular from the top of the boy to the building like this. I'll call this point as A and this point as B. Now the boy is seeing the building, the top of the building, and the angle of elevation is 30 degree like this. I'll call this point as C, and he is walking towards the building, and at some point he sees the top of the building. Now the angle of elevation is 60 degree like this. So I'll call this point as D. Now the question is, what is the distance of AD? What is the distance of AD is the question. Now what is the length of BC? Top the height of the building is 30 meters, and the height of the boy is 1.5 meters. So 30 minus 1.5 is 28.5. 28.5 is the length of BC. Okay. Now with respect to angle A, what is tan A? Okay, what is tan A? Tan A is opposite by adjacent, that is BC by AB. Okay. Now tan A, what is the value of tan A? You can see in the chart, that is tan 30 degree. Tan 30 degree is 1 by root 3. So 1 by root 3 is equal to BC. BC is 28.5 by AB. AB is unknown, and that's what we need to find out. So now AB, when we cross multiply, AB is equal to 28.5 into root 3 I will get. Now what is tan of angle D? With respect to angle D, tan of D is tan of 60 degree. Okay, tan of 60 degree. Tan of 60 degree is opposite by adjacent, that is BC by DB. So what is the value of tan of 60 degree? You can see in the chart, tan of 60 degree is root 3. So root 3 is equal to BC. BC is 28.5 and DB is unknown, DB. So DB, now DB, when we cross multiply, we get DB is equal to 28.5 by root of 3. Now what is AD? AD is equal to, you can see in the figure, AD is equal to AB minus BD. Okay, what is the value of AB? Okay, AB is 1. Okay, that is AB is 28.5 root 3 minus BD or DB, that is 2. That value is 28.5 by root 3. Now here 28.5 into root 3 means that is 28.5 by root 3 by 1. So what is the LCM of 1 and root 3? Yeah, LCM of 1 and root 3 is root 3 only. So root 3 I'll take in the denominator, and then in the numerator I'll get 28.5 root 3 into root 3 I'll get, because LCM is root 3, minus 28.5 So here root 3 into root 3 is root 3. So 28.5 into, sorry, root 3 into root 3 is just 3. So 28.5 minus 28.5 minus 28.5 by root 3. Now I will take 28.5 as common factor. 28, then the remaining is 3 minus 1 by root 3. So here I will get 28.5 into 2 by root 3. Now denominator is an irrational number, so I will multiply and divide by root 3. So I will get 28.5 into 2 into root 3. So denominator root 3 into root 3, I will get just 3. Now 28.5 into 2, how much? 2 5s are 10, 2 8s are 16, 17, 2 2s are 4, 5, 57.0, that is 57. 57 by 3 into root 3. So now 3 1s are 3, 3 9s are 27. So 19 root 3 meters is the answer. This is AD. So the boy walked 19 root 3 meters. Exercise 12.1, question number 7. From a point on the ground, the angles of elevation of the bottom and the top of the transmission tower fixed at the top of a 12-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. So there is one tower which is placed on the top of the building, and the building's height is 20 meter. Upon this building there is one tower, and from the ground the angle of elevation of the top of the tower and the bottom of the tower, this is the top of the tower, this is the bottom of the tower. So angle of elevation are 45 degree and 60 degree. So this is 60 degree. Okay, I'll mark this as A, I'll mark this point as B, this point as C, this point as D. We should find the height of the tower, that is, what is the length of CD? That's the question. So before finding CD, I'll find AB. Okay, to find AB, now what is tan of 45 degree? So tan of 45 with respect to angle A, tan of 45 is opposite by adjacent, that is BD by AB. So tan 45, what is the value of tan of 45? You can see in the chart, tan of 45 degree is 1. So tan of 45 degree is 1. Therefore 1 is equal to BD. So BD is nothing but 20 meters, that is the height of the building, 20 by AB. So now AB is equal to 20 by 1. If I cross multiply, 20 by 1 is 20. So AB is 20 meter. Now what is tan of 60 degree with respect to angle A? Tan of 60 degree is equal to opposite with respect to angle A. Opposite side is, now it is BC by AB. So tan of 60 degree, from the chart you can see tan of 60 degree. Tan of 60 degree is, from the chart you can see it is root 3. So root 3 is equal to BC by AB just now we found it is 20 meters. Okay, or now BC is equal to, when we cross multiply, 20 root 3 will get. Now what is CD? CD is the height of the tower. CD is equal to BC minus AB. Okay, BC how much? 20 root 3. AB is 20. So this is equal to 20 is common, 20 into root 3 minus 1 meters is the answer. The height of the tower, that is CD, is equal to 20 into root 3 minus 1. Exercise 11.1, question number 8. This is similar to question number 7. A statue 1.6 meter tall stands on top of a pedestal. From the point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. So there is one statue which is on top of the pedestal, okay, like this, and the statue height is 1.6 meter tall, and from the ground the angle of elevation of the top of the statue is 60 degree. So this is this angle is 60 degree, and also from the same point the angle of elevation of the top of the pedestal. Top of the pedestal is this. Top of the pedestal is also the bottom of the statue. Okay, this is top of statue, and this is top of pedestal or bottom of the statue. Okay, top of pedestal. So from this point the angle of elevation of the top of pedestal is 45 degree. Okay, I'll mark this as A, this as B, this as C, and this point as D. Now what is with respect to angle A, tan of A is equal to tan of 45 degree is equal to, with respect to angle A, tan of 45 is opposite by adjacent, that is BD by AB. So what is tan of 45 degree? Tan of 45 degree, you can see the chart, tan of 45 degree is 1. So 1 is equal to BD by AB, or AB is equal to BD. Okay, I'll mark this as 1, I'll keep it as it is. Now what I'll do is I'll take tan of 60 degree. Now tan of 60 degree is opposite by adjacent, that is with respect to angle A, opposite side is now BC by AB. Okay, now what is tan of 60 degree? Tan of 60 degree from the chart you can see it is root 3. So root 3 is equal to BC is also equal to BD plus DC by AB. Okay, now root 3 is equal to, I'll split the right hand side, I'll write BD by AB plus DC by AB. Now I know the value of DC. DC is nothing but the height of the statue, that is 1.6 meter. So root 3 is equal to BD by AB. So BD by AB, but AB is also equal to BD. Okay, from equation 1. Okay, that one I am substituting here, and DC is 1.6 meter by AB. So root 3 is equal to BD by BD plus 1.6 by AB. So from 1 I substituted AB is equal to BD. Now here BD will get cancelled, I will get 1. So root 3 is equal to 1 plus 1.6 by AB. Now if I take 1 to the left hand side, I'll get root 3 minus 1 is equal to 1.6 by AB. Now if I cross multiply, I'll get AB into root 3 minus 1 is equal to 1.6, or AB is equal to 1.6 by root 3 minus 1. So denominator is a irrational number, so if to rationalize it, I should multiply and divide by root 3 minus 1. So AB is equal to 1.6 by root 3 minus 1. So I will multiply both numerator and denominator by root 3 minus 1. So root 3 minus 1. Now 1.6 into root 3 minus 1 in the numerator. So denominator, sorry, I'll multiply by root 3 plus 1. So now what is a plus b into a minus b is a square minus b square. So here I'll get root 3 the whole square minus 1 the whole square. So this is equal to 1.6 into root 3 minus 1 by root 3 the whole square is root 3 the whole square is 3, okay, minus 1 square is 1. So this I'll get 1.6 into root 3 minus 1 divided by 3 minus 1 is 2. Now 1.6 divided by 2 is, I'll keep 1 point. Now 2 8s are 16, okay, get 0. So this is 0.8 into root 3 minus 1 meters is the answer. So that is what is AB. AB is also equal to BD, okay. So BD is the height of the pedestal. So BD is 0.8 root 3 into root 3 minus 1 meters. Exercise 12.1, question number 9. The angle of elevation of the top of a building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. First read the question properly, understand, and then only proceed, okay. So there is one tower and one building, okay, and the height of the tower is 50 meter, okay. This is tower, this is building, and from the foot of the tower, the angle of elevation to the top of the building is 30 degree. So that is, this is 30 degree, and from the foot of the building, the angle of elevation to the top of the tower is 60 degree. So this is 60 degree here. Now I should find the height of the building, okay. I'll name this as A, B, this as C, and this as D, okay. Now first to find the height of the building, what I'll do is, first I'll find AB, the distance between the foot of the tower and the foot of the building. AB I will find, okay. So now with respect to angle B, okay, tan of B, that is tan of 60 degree is equal to opposite by adjacent, that is AD by AB, okay. So tan 60, what is the value of tan of 60 degree? So you can see in the chart, tan of 60 degree is root 3. So root 3 is equal to AD we know it is 50 meter by AB is unknown. So AB is equal to 50 root 3. So if I multiply, so root 3 is a irrational number, so I can multiply and divide by root 3 to make it a rational number. So root 3 is an irrational number, so I'll multiply and divide by root 3, so that denominator will become irrational number. So 50 root 3 into root 3 is 3. Okay, so 50 by 3 into root 3 is the height of is the length of AB. Now with respect to angle A, tan of 30 degree is equal to opposite by adjacent. Okay, this is tan A. Tan A is tan 30 degree. So with respect to angle A, this is now opposite by adjacent, that is BC by AB. So tan of 30 degree, what is tan of 30 degree? You can see in the chart the value of tan of 30 degree is 1 by root 3. So 1 by root 3 is equal to BC by AB. Okay, or BC is equal to, when we cross multiply, BC is equal to AB by root 3 I will get. So or BC is equal to AB. What is AB? So AB we found out from 1. So substitute that value here. AB is 50 root 3 by 3 into 1 by root 3. So here root 3 will get cancelled. I will get 50. Sorry, 50 by 3. So 50 by 3, if we divide, 3 ones are 3, then 2 0 3 6 are 18. So 16. So BC is equal to 16 2 by 3 meters. So that is the height of the building is 16 2 by 3 meters. Exercise 11.1, question number 10. Two poles of equal heights are standing opposite each other on either side of the road, which is 80 meters wide. From a point between them on the road, the angle of elevation of the top of the poles are 60 degree and 30 degree respectively. Find the height of the poles and the distance of the point from the poles. So there is a road whose width is 80 meter. Okay, and on either side of the road there are two poles of equal height. Okay, I'll call this as D is one pole and BC is another pole, and there is one point between the poles on the road, and the angle of elevation of the top of the poles are 60 degree. One angle of elevation is 60 degree and the other angle of elevation is 30 degree to the top of the pole. Now I should find the height of the pole, that is D I should find, and BC I should find, and also find the height of the pole and the distance of the point from the poles. That is, I should find I'll call this point as A. I should find EA and AB. Okay, first read the question, understand properly, and then only you proceed. Okay, now what is tan of A? Tan of A, I'll take first time angle A I'll take as 30. So what is tan of 30 degree? Tan of 30 degree with respect to angle A, tan of 30 degrees opposite by adjacent, that is BC by AB. Okay, and what is the value of tan 30 degree? So you can see in the chart, tan of 30 degrees 1 by root 3. So 1 by root 3 is equal to BC by AB. Okay, or when you cross multiply, BC is equal to AB by root 3 you will get. Okay, I'll mark this as 1. Now similarly, what is tan of 60 degree with respect to angle A? Tan of 60 degree, if I see towards the left of angle A, okay, so tan of 60 degree is opposite by adjacent, that is D by EA I will get, or AE. So tan of 60 degree is, from the chart you can see it is root of the 3. So root 3 is equal to D. D is unknown, and EA. So EA I'll write as it is. When we cross multiply, we will get DA as D is equal to root 3 times of EA. I'll mark this as 2. But the height of the poles are equal, that is D is equal to BC. Okay, so 1 and 2 are equal. So since D is equal to BC, AB by root 3 is equal to root 3 into EA. Okay. Now what is the relation between EA and AB? EA plus AB is equal to 80 meters. Okay, the width of the road is 80 meters, that is the distance between the poles is 80 meters. EA plus AB is equal to 80 meters. Therefore EA is equal to 80 minus AB. Okay, now in place of EA I'll substitute 80 minus AB. So AB by root 3 is equal to root 3 into 80 minus AB. So AB by root 3 is equal to, so now I'll open the bracket, root 3. So root 3 into 80 is 80 root 3 minus AB into root 3 is root 3 into AB. Now I will bring AB to the left hand side. So AB term to the left hand side, AB by root 3. So if I bring this to the left hand side, AB by root 3 plus root 3 into AB is equal to 80 root 3 I will get. Or now I will take AB as common factor in the left hand side. So AB into 1 by root 3 plus 1 by root 3 plus root 3 is equal to 80 root 3 I will get. Now in the left hand side, root 3 means it is root 3 by 1. So now AB into 1 plus root 3 by 1. So here LCM of root 3 and 1 is root 3. So 1 plus, now in the numerator I will get 1 plus root 3 into root 3. Okay, this is equal to 8 into root 3. Okay, now this AB into, so 1 plus root 3 into root 3 is just 3 I will get by root 3 is equal to 80 root 3. Now AB 1 plus 3 is 4 by root 3 is equal to 80 root 3. Now if I cross multiply, AB is equal to 80 into root 3. Now from the left hand side 4 by root 3 is there. If I bring to the right hand side, root 3 will go to the numerator and 4 will come to the denominator. Now 4 ones are 4, 4 ones are 4, 4 twos are 8, 4 zeros are 0. So I'll get 20 into root 3 into root 3. So root 3 into root 3 is again 3. So 20 into 3. So this is 60. So AB is equal to 60 I'll get. So if AB is equal to 60, if AB is equal to 60, what is EA? EA is equal to, so EA is equal to 80 minus 60 is equal to 20 meters. So AB is 20 meters and AB is 60 meters and EA is equal to 20 meters. EA once again I am writing, EA is equal to 80 minus 80 minus AB. So this is 80 minus AB is 60. So EA is equal to 20 meters I will get. AB is equal to 60 meters and EA is equal to 20 meters. And what is DE? From equation 2 you can see that D is equal to root 3 times of EA. Okay, D is also equal to BC. Both these are the height of the towers, that's it. Okay, so root 3 into EA is 20. So 20 root 3 meters. So DE and BC are the height of the towers. They are equal to 20 root 3 meters. Exercise 12.1, question number 11. A TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite the tower, the angle of elevation of the top of the tower is 60 degree. From another point 20 meters away from this point on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degree. Find the height of the tower and the width of the canal. So the diagram is here like this. This is the TV tower. It is standing on one side of the canal. The other side of the canal is point C. Okay, and angle of elevation at this point is 60 degree, and at another point D, the angle of elevation is 30 degree, and point D is 20 meters away from C, and all D, C, B are in the same straight line. Okay, now I should find the height of the tower, that is AB, the length of AB I should find, and also CB, what is CB I should find. Now what is tan of 30 degree? Tan of 30 degree is with respect to angle D, opposite side is AB and adjacent side is DB. So what is the tan of 30 degree? Tan of 30 degrees, you can see in the chart, it is 1 by root 3. 1 by root 3 is equal to AB by DB, or when we cross multiply, AB is equal to DB by root 3 I will get. Okay, this I will mark as 1. And also what is tan of 60 degree? Tan of 60 degree with respect to angle C, tan 60 degree is opposite, that is AB, by adjacent, that is CB. So this what is the value of tan of 60 degree? Tan of 60 degree is root 3. From the chart you can see root 3 is equal to AB by CB, or when we cross multiply we get AB is equal to root 3 into CB. Okay, now you can see left hand side of 1 and 2 are same. Okay, therefore I can equate the right hand side, that is DB by root 3 is equal to root 3 into CB, or DB is equal to, when we cross multiply, root 3 into CB I will get. So root 3 into root 3 is just 3 into CB. DB is equal to root 3 into CB I will get. Now what is the length of BD? This I will mark as equation 3. BD is nothing but DC plus CB, right? So now, but BD or DB is 3 times of CB. From equation 3 we derived it. DB is 3 times of CB. I will substitute that. 3 times of CB is equal to DC plus CB. Okay, from 3 I substituted dB. So now 3 CB, this CB on the right hand side I will bring to the left hand side. So 3 CB minus CB is equal to DC I will get. So 3 CB minus CB is 2 CB. 2 CB is equal to DC, or CB is equal to DC by 2 I will get. What is DC? DC we already know, it's given in the data, that is 20. 20 by 2 is equal to 10. So CD, sorry, CB, okay, this is CB. So CB is equal to 10 meters. So CB is nothing but the width of the bank. Now I should find the height of the tower. See equation 2. What is equation 2? Equation 2 is AB is equal to root 3 times of CB. So AB is equal to root 3 times of 10. So that is 10 root 3 is the height of the TV tower. Exercise 12.1, question number 12. From the top of a 7-meter high building, the angle of elevation of the top of the cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. So there is one building whose height is 7 meter and there is another tower. Now, so both, it's obvious that both this tower and building are on the ground. That means they lie on the same horizontal. From the top of the building, if I see the top of the tower, the angle of elevation is 60 degree, and if I see the foot of the tower, the angle of depression is 45 degree. Okay, I'll mark this as A, this as B, and this as C, and this as D, this as E. Now I should find the height of the tower, that is what is CD I should find. Okay, now A is 7 centimeter, therefore BD also will be 7 meter only. A is 7 meter, BD also will be 7 meter only. So now what is tan of 45 degree? Tan of 45 degree is opposite by adjacent, that is BD. With respect to angle A, 45 degree, opposite side is BD. BD by AB is adjacent side. So tan of 45 degree, what is the value of tan of 45 degree? From the chart you can see it is 1. 1 is equal to BD by AB. When we cross multiply, 1 into AB is equal to BD. 1 into AB is AB only. So AB is equal to BD. So AB is equal to BD I will get. That means AB is also equal to 7 meters. Okay. Now what is with tan of 60 degree? Tan of 60 degree with respect to angle A, tan 60 is opposite by adjacent, that is CB by AB. So what is the value of tan of 60 degree? In the chart you can see tan 60 degree is root 3. So root 3 is equal to CB by AB. AB we just calculated, it came out to be 7 meters. Therefore now if we cross multiply, CB I will get as 7 into root 3. Okay, or CB is 7 root 3. Now what is the height of the tower? Height of the tower is given by CD is equal to CB plus BD. So CB just now, CB or BC, just now I calculated, it came out to be 7 root 3 plus BD is 7 meters. So 7 is common factor, root 3 plus 1. So this is 7 into root 3 plus 1 meters is the height of the tower. Exercise 12.1, question number 13. as observed from the top of a 75-meter high lighthouse from the sea level, the angles of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the ships. So in seashore there will be something called as a lighthouse. Okay, from the top we can monitor the movement of ships. So one ship is somewhere here. Okay, this is the ship, and another ship is somewhere here, and the angle of depression, from angle of depression, that means from the top, if I see the ship, the first ship is visible at an angle of depression of 30 degree. That means that is this angle. Okay, I'll join this. So the height of the lighthouse is 75 meter height. 75 meter height. Okay, I'll call this point as A, and this as B, C. So the angle of depression of one ship is 30 degree. That means this also will be equal to 75 meters, and the angle of depression of another ship is 45 degree. That is this angle. Okay, this angle is 45 degree. So that means I'll mark this as D, E. So D also will be equal to 75 meters. The angle of depression of the two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So this distance I should find. Okay, this what is EC? That's the question. Now with respect to angle A, what is tan of A? Tan of A, I'll take A as 30 degrees. So with respect to angle A, tan 30 degree. Tan 30 degree is opposite by adjacent. So the opposite side is BC. BC by adjacent side is AB. So tan 30 degree, what is the value of tan 30 degree? You can see in the chart, tan 30 degree is 1 by root 3. So 1 by root 3 is equal to BC. BC is 75 meters. And AB is unknown. So AB, now if I cross multiply 1 into AB is equal to 75 into root 3, or 1 into AB is AB only. AB is equal to 75 root 3. Okay, now what is tan of 45 degree? Tan of 45 degree with respect to angle A, tan 45 degree is opposite by adjacent, that is which is equal to opposite. Now it is D. Tan 45 is D by adjacent side is AD. So tan for 45 degree, you can see in the chart the value of tan 45 degree is 1. So 1 is equal to D. D is 75 meters. 8 by AD. When I cross multiply, 1 into AD is equal to 75. 1 into AD is AD only. So AD is equal to 75 meter. Now what is dB? Okay, dB is equal to AB by AB minus AD. Okay, what is the value of AB? AB is 75 root 3. 75 root 3. What is AD? AD is 75. So 75 is common. 75. So root 3 minus 1 meters. This many meters is dB. But dB is also equal to EC. So EC is equal to 75 into root 3 minus 1 meters. So this is the distance between the two ships. The next problem in exercise 12.1 is question number 14. 1.2 meter tall girl spots a balloon moving with the wind in the horizontal line at a height of 82.2 meter from the ground. The angle of elevation of the balloon from the eyes of the girl at any instance is 60 degree. After some time, the angle of elevation reduces to 30 degree. Find the distance traveled by the balloon during the interval. So the height of the balloon, height of the girl is 1.2 meters, and balloon is flying at an altitude of 82.2 meters. Okay, I'll call this point as A. So at an angle of elevation of 60 degree, balloon is spotted. We'll call this point as C, this as B, and after some time the balloon moves to point D, let us say D, and now the angle of elevation is 30 degree. Okay, 30 degree. Now I'll call this point as F. Now the altitude of the balloon is same, it's not changing, that is 82.2 meters. So now what is BF, sorry, what is CB? CB is equal to DF. So this is equal to 82.2 minus 1.2. The height of the girl is 1.2 meters, so 82.2 minus 1.2 is 87.0 or 87. Okay, CB, both CB and DF will be equal to 87 meters. Now what is tan of 60 degree? Tan of 60 degree is opposite by adjacent, that is CB by AB. Okay, now what is tan of 60 degree? Tan of 60 degree, the value of tan of 60 degree in the chart you can see it is √3. So √3 is equal to CB, the value of CB is 87. Okay, 87 meters by AB, or AB is equal to 87 by √3. So now I can factorize this one, factorize the denominator, that means I'll multiply and divide by √3. So 87 √3, 3 into 3 is √3 into √3 is 3 only. So 3 1s are 3, 3 2s are 6, 3 9s are 27. So 29 √3 I'll get as AB, the length of AB. Now what is tan of 30 degree? Tan of 30 degree is equal to opposite by adjacent, that is DF by AF. So now DF, tan of, what is the value of tan 30 degree? It is 1 by √3. So this is equal to DF is 87, we found out. Okay, and A by AF, therefore AF is equal to 87 into √3. Okay, now what is the distance traveled by the balloon? Distance traveled by the balloon is CD. CD is also equal to BF. Now what is BF? CD is equal to BF. BF is equal to AF minus AB. What is AF? AF we found it is 87 √3. And what is AB? AB we found it to be 29 √3. So √3 is common. So 87 minus 29 into √3. 87 minus 29, how much? 17 minus 9 is 8. 7 minus 2 is 5. 58 √3 meters is the distance traveled by the balloon. Exercise 12.1, question number 15. A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. So there is an highway leading to a foot of the tower. Okay, so the angle between highway and tower will be 90 degree. So first the car is approaching the foot of the tower, and one person standing at the top of the tower observes the car, and the angle of depression is 30 degree. Okay, so that means if I draw one line parallel to the ground, Okay, now this angle is 30 degree. So when one man is watching this car at the top and the angle of depression is 30 degree, I'll extend this horizontal line. Now I'll draw perpendicular from this point like this, and let these two lines meet here, making an angle of 90 degree here. Now the car from this point, I'll say point A. When the car was at point A, the angle of depression was 30 degree, and the car now moves to another point, let us say point D. Okay, when the car moves to point D, the angle of depression was found to be 60 degree. That means this angle is equal to 60 degree. Okay, now I'll draw one perpendicular from point D to the horizontal line above. Now this angle will be equal to 90 degree. Now I'll name this point as B, and this point as E, this point as C, and this point I'll mark as F. Now let the length of the tower be some x units. Okay, we'll assume that the height of the tower be x units. Okay, now the car took 6 seconds to travel from point A to D. Okay, 6 seconds it took. Now how much time it took the car to move from point D to F is the question. Okay, now if CF is equal to x units, D also will be equal to x units, and AB also will be equal to x units. Now with respect to point C, what is tan of 30 degree? So consider triangle ABC now. So tan of 30 degree is opposite by adjacent, that is AB by BC. So tan 30 degrees 1 by root 3, value of tan 30 degrees 1 by root 3, and AB, the length of AB is x units, and by BC is unknown. Now if I solve for x, that means I'll cross multiply. Now I'll get BC by root 3 is equal to x. So I have solved for x. Okay, now similarly here consider triangle DEC. Now here tan of 60 degree is opposite by adjacent. So opposite side is ED, and adjacent side is EC. Now what is ED? The length of ED is x units. Okay, we have assumed it has to be x units. Now what is the value of tan 60 degree? Tan 60 degree is root 3. So x by EC I will get. Now if I solve for x, I will get root 3 into x is equal to EC. I will mark this as 2. Now I will solve for x. I will get root 3 into EC is equal to x. I will mark this as 2. Now right hand side of 1 and 2. So in equation 1 and 2, both the right hand side are same only. RHS of 1 and 2 are same. Therefore left hand side also will be equal now. Therefore LHS also is the same. That means I can equate the left hand side, that is BC by root 3 is equal to root 3 into EC. Now if I cross multiply, I will get BC is equal to root 3 into root 3 into EC. What is root 3 into root 3? Root 3 into root 3 is just 3 EC. So BC is equal to 3 EC. Okay, this I will mark as 3. Now in the diagram you can see that the length of BC is equal to BC is equal to BE plus
EC. Okay, now BC, what is BC? BC is equal to 3 EC. Okay, you can see equation 3. Equation 3 says BC is equal to 3 EC. I am substituting the value of BC here. So 3 EC is equal to BE plus EC. How I got this one? From equation 3. Okay, now 3 EC minus EC, I will bring this to the left hand side, is equal to BE. So 3 EC minus 1 EC. EC means just it is 1 EC. So I will get 2 of EC. 2 EC is equal to BE, or EC now is equal to B by 2. Now in the diagram you can check B is also equal to AD, and EC is also equal to DF. Okay, so EC is equal to B by 2. That means AD is equal to DF. Sorry, DF. Okay, DF is equal to AD by 2. Now to travel length, okay, to travel length DF, it took 6 seconds. Okay, therefore to travel length AD, sorry, this is AD. To travel AD took 6 seconds. Therefore to travel DF, it will take half of it. Okay, it will take 6 by 2 seconds. Okay, since DF is half of AD, so the time taken to travel by the car will be equal to 6 by 2, which is equal to 3 seconds. And that completes this problem. Exercise 12.1, question number 16. The angle of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meter. So there is one tower and the angle of elevation. Okay, angle of elevation is not known. From the foot of the tower at a distance of 4 meter. Okay, and again in the same direction at a distance of 9 meter, there is some angle of elevation to the top of the tower. Okay, so this is 4 meter and this distance is 9 meter. I'll mark this as A, B, C, this as D. So let the angle of elevation be x degree, y degree. So there is some angle of elevation, okay, at this distance from the foot of the tower to the top of the tower. I should prove that the top of the tower height is 6 meter. That one I should prove. Okay, so given x degree plus y degree is equal to 90 degree. Okay, that's what the question says. These two angles are complementary. Complementary means sum of them will be equal to 90 degree. And prove that BC is equal to 6 meter. I should prove that the height of the tower is 6 meter. Now x plus y is equal to 90 degree. Therefore y is equal to 90 minus x. I will take tan on both sides of 1. Okay, this I will mark as 1. Therefore tan of y is equal to tan of 90 minus x. Okay, so tan of y. So tan of 90 minus x, what is that? So tan of 90 minus x is cot of x. So in complementary angles you have studied, sine will change to cos, cos will change to sine, tan will change to cot, cot will change to sine when in case of complementary angles. So here x and y are complementary angles, that's why tan y is equal to cot of x. This I'll mark as equation 2. Now what is tan of x degree? Tan of x degree is opposite by adjacent, right? So that is opposite is CB or BC. Okay, BC by AB. So BC by AB, BC I'll keep it as it is, still it is unknown. It is 6 meter. We should prove that. So until then we'll assume BC is unknown. So BC by AB, AB is 9 meter. So what is, okay, tan, this is tan of x degree. So if I cross multiply, I'll get 9 tan of x degree is equal to BC. Similarly, what is tan of y degree in the diagram? Check it. So with respect to point D, tan y degree is opposite by adjacent, that is BC, and BC by BD. So BC, it's unknown, BD is 4 meter. This is tan of y degree. So if we cross multiply, 4 tan of y is equal to BC I will get. Now this I will mark as equation 3, this I will mark as equation 4. Now equation, right hand side of equation 3 and right hand side of equation 4 are equal. So I will mention that sentence. Right hand side, RHS of 3 and 4 are equal. Therefore LHS are also equal. So that means I can equate the left hand side, that is 9 into tan x is equal to 4 into tan y. I can equate like this. Now if I cross multiply, 9 by 4 is equal to tan of y by tan of x. Okay. Now 9 by 4 is equal to, now tan of y is equal to cot of x by tan of x. From this I got from equation 2. In equation 2 we derived that tan of y is equal to tan of x. Therefore in the numerator, in place of tan y I will write as cot of x. So 9 by 4 is equal to, now what is cot? Cot of x. Cot of x is 1 by tan of x into the tan of x as it is. So cot x, tan x are inversely related. Okay, cot theta is equal to 1 by tan theta and tan theta is equal to 1 by cot theta. They are inversely related. Therefore cot of x is 1 by tan x. So 9 by 4 is equal to 1 by tan x into tan x is tan square x. Now if I take reciprocal, taking reciprocal, I will get 4 by 9 is equal to tan square x. I did nothing. Taking reciprocal means change bring numerator to denominator and denominator to the numerator. Both side I should do, left hand side and right hand side, both side. So 4 by 9 is equal to tan square by x. Tan square by x by tan square x by 1 is tan square x only. Now in the right hand side, power of 2 is there. So to remove that, I'll square both sides. Square both sides, I'll get square root of 4 by 9 is equal to square root of tan square x. So square root of 4 is 2, square root of 9 is 3. So square root of tan square x is tan x only. Now what is tan x? in the figure you can see tan x is also equal to opposite by adjacent, that is BC by AB, BC by AB. Now 2 by 3 is equal to, what is BC? BC is unknown, still it is unknown. What is AB? AB is given as, it is 9 meter. Point A is 9 meters away from the foot of the tower. Now if I cross multiply, what will I get? 2 into 9 by 3 is equal to BC. 3 1s are 3, 3 2s are 3 3s are 9. So 2 3s are 6. 6 is equal to BC, or BC is equal to 6 meter. BC is nothing but the height of the tower, and that proves, and that completes the question and this exercise.